Okay, hello, good morning. In this video, I'll start talking about the wing and basically Newton's third law and how it applies to aerodynamics. If you haven't already gone over the lift equation or we haven't gone over Bernoulli's principle, I would really suggest looking at those videos now before we go into this one. But okay, so let's start talking about the wing itself. Now, when people explain the wing, the thing that they do is they like to draw a drawing of the wing. So I'll go ahead and do that right now. There you go. So let me go ahead and I'll take my little paint tool here and start drawing the wing. And I think I'm going to go ahead and put it like this. There we go. That looks pretty good. I like that. Okay, with this right here, this is a cross section of your typical airfoil surface. Cross section meaning that you take the wing and you cut it in half, and that's if you were looking at it straight on, like if the plane was on the ground and you were looking standing on the side, looking from the left side to the right side. It's also known as a profile view in some concepts, but essentially this is your cross section of the wing. Now what we have here is it's an airfoil, and an airfoil is any type of surface that's designed to generate lift, either from a fluid moving over it or it moving through a fluid. Now, not all wings are, or not all airfoils are wings. All wings are airfoils, but not all airfoils are wings. And that may not make any sense, but until you realize that aerodynamics plays more of a part in more aspects of life than just aviation. Cars will have airfoil surfaces. They'll have splitters, they'll have wings on the back, they'll also have canards, if you will. Lift can be generated in more than one direction. Also, it can be generated in a downward direction. It can also be generated in a forward direction. In fact, that's how propellers work, but we'll start talking more about that later. But back to the wing itself, to really understand the concept of how the wing works and how it is designed to generate lift, first you want to take the design of the wing and then break it down into more take a complex design and you break it down into a more easier, manageable area to work with. So what I mean by that is that let's say I were to draw a line from here to here. Then what you do is now the wing is split in half, and then we can talk about it more in detail. Okay, so the top part of your wing is from here to here. That is known as camber. And camber is simply being the curvature of the wing from your leading edge to your trailing edge. Now, this bottom part right here is also camber. So camber is simply the curvature of the top part of the top surface of the wing and the bottom surface of the wing. And that actually leads to a lot of stuff right there. This ties into Bernoulli's principle, this ties into other elements. But for right now, I just want you to get interested in the verbology behind it. Now, this part of the wing right here is known as the leading edge. And this is known as a trailing edge. And then, so this would be the front of the airfoil, that would be the rear of the airfoil. This line right here is known as your chord line. Your chord line basically being that if you were to draw a straight line from your wing tip, or from your leading edge to your trailing edge, then that would be the line that it would take. Now you also have another line also, and it's basically it's an imaginary line. Well, all these lines are actually imaginary except for the airfoil itself, but then you have another line which is known as your mean camber line, and basically it's the average chord or the average camber with your top of the wing and the bottom of the wing. So this is the basic phraseology behind the wing, and I'll go ahead and end the video right here, and then in the next video I'll start talking about how the wing interacts with the airflow to generate lift. But this is some good phraseology that you'll want to know.